Hello, my name is Mark Irving and I'm the Technical Manager of PorjectDSM Proprietary Limited. This talk will introduce PorjectDSM, the application, to you. We at PorjectDSM Proprietary Limited started in 2005 when a number of project managers and technical managers realised there wasn't an easy way for small and medium-sized enterprises to pick up and use the DSM methodology. We were intrigued by the DSM methodology and could see how it could help us deliver our projects quicker with less rework and waste, fitting into a lean development methodology. PorjectDSM allows you to create both time-based projects and static architectures and optimize those projects and architectures using either a clustering or a partitioning approach. In both cases, what we're trying to do is analyze our projects to understand some of the inner workings and the analysis of the dependencies between actions or elements of our projects. We wanted to make PorjectDSM easy to use by giving you a number of hints, tips and wizards to guide you through the process of defining project data and to analyze the project. So what we're trying to do is make the program easy to use for those who are new to the DSM methodology. So you can see here the blue text are our explainers. We have pop-up tips to help you push the right buttons at the right time, and we have data entry wizards which guide you step by step through the process of creating a project. There are two main ways you can use PorjectDSM. Firstly, you can look at static systems, which are product architectures, a structure of teams within an organization. So architectures which have no time relation between the elements but have some dependency relationship between those elements. In a product architecture, we can show the dependencies in a DSM and use clustering analysis to try and group groups of elements which have got connection together and less connection to those other elements outside the group. Our clustering algorithms are optimized to produce clusters with the maximum number of elements within them, with the largest number of links or dependencies amongst them, and to minimize the number of dependencies to elements outside the cluster. The clustering algorithm is non-deterministic and uses a statistical process to determine those clusters. You can see here in the diagram a product architecture, and the algorithm has produced a number of suggested clusters to group elements together. We also have the concept of integration elements. These are elements which often have connection across an entire project, and by marking them as integration elements we can improve the clustering by removing them from the actual problem at hand. You can also see within this slide that we also color code our elements, so that if we have elements within a hierarchy, we can actually show those arms or those subtrees within the hierarchy via color. The other type of projects we can use within the DSM are time-based or project plans. And in these ones we're trying to optimize the cost, the effort, the time to delivery, and more importantly to try and identify where rework could occur and to try and avoid it. In order to enter a project within PorjectDSM, we identified project tasks, we estimate costs and resources for those tasks, we define dependencies, and within that project dependency step we also have a way of double checking that we have considered all the different possible dependency within the system. And if we add tasks later to the project, that when we go in again and reconsider those dependencies, we have a way of marking which elements have been considered and which elements are yet to be considered. And once we have defined all the tasks and dependencies, we can use the DSM methodology to identify the iteration blocks within the project and try and optimize the project sequence to minimize the potential for rework and for waste in the project. So you can see here a DSM which has in the traditional format showing the elements down the side, the dependencies as red dots between linked activities, and the iteration blocks are the pink blocks which show tightly coupled activities within the project. The advice wizard allows us to either simplify the iteration block by marking an activity to be done at the beginning of the block, the end of the block, or removing a particular dependency which will break the block into smaller blocks. The tearing wizard shows us a number of simplifications we can make and gives us an estimate of the reduction in complexity of the project and the amount of cost or effort which would be impacted by that complexity reduction. And so we can target both trying to minimize the amount of rework in cost terms or in effort terms. You can see in this slide a project which initially has been entered into the system and has a random project sequence, and then after partitioning, the sequence has been redefined to give us mostly sequential activities with one particular iteration block. And with that iteration block, we have promoted 2 activities to the end of the block, thereby disabling a number of feedback dependencies. And so we have now a project plan which has removed the iterations by making a number of assumptions as far as moving an activity to the end. In order to manage iteration blocks, we have been removing dependencies or tearing those dependencies, and this has generated a number of assumptions which are taking the place of those dependencies. Within the application, we manage those assumptions so they are explicit and that we check that those assumptions will be met in the execution of that project. Another view we show within PorjectDSM is the linchpin view. Linchpins are defined as those activities which have a large impact on subsequent activities. So you can think of these linchpin activities as either those activities which have a lot of dependent cost or activity associated with them, and often linchpin activities may or may not be on the critical path. So they may not be time critical, but they may be project critical. That if there is a failure or a lack of that activity delivering what it was meant to deliver, that could have a large impact on subsequent activities. And so by identifying those linchpins, we can better manage the project. Finally, we show a Gantt chart of the project, which has the traditional view of showing the critical path and activities which can be floated which are not on the critical path, but we also show the iteration blocks as the beige blocks within the Gantt chart. This illustrates examples of, if we look at the small block starting at activity 33, here we have an iteration loop consisting of 3 tasks on the critical path. And so when we traditionally would manage that strongly, we would actually probably also look after the iteration activities and potential for rework. But in the following iteration loop, you can see that only 3 activities are on the critical path, but we have 3 other activities with significant float which are part of that potential iteration block. If we have a breakdown in our assumptions which we've made, we might see those activities repeated because they are in a codependency block. And so you can see here, this is one area where the DSM analysis helps us identify the risk in our project for activities which might not be on the critical path, could still affect the critical path by their feedback in the dependency loops. Thank you for your patience in listening to this presentation, and I hope you've learnt something of our application PorjectDSM. You can always go to our website at www.PorjectDSM.com and download our application, which you can use for free for 2 weeks to evaluate. I hope that you take time to look at our application, and if there are any questions, please contact us via the contact links on our website. Thank you very much.